Good morning, all the students. How are you? I hope you all are best and fine. Now we are going to discuss about the yesterday's concepts. Yeah. In the last class, we are already discussed about that fifth problem. Now at our sixth problem, one second. The displacement of the particle in a 50 second is a 32 meters. In a 60 second is a 36 meter. Pick out the correct statements. Okay. Yes, all the students yesterday same as like that yesterday problem only. This is once you solve it, there is you have to tell get a what two equations. What is the equation especially? Sorry. Yeah, next one, there is what we are considered. This is 32. Next we are considered 36 is equal to u plus a by 2 into 2 into 6 minus 1. This is the equation number 1. This is the equation number 2. So you have to solve it. You get it is okay. Clear or not, all the students? Now, okay. Check the final equations. What is they get for us? And the 32 is equal to taken as u plus a by 2 into 10 minus 1. Okay, clear or not? 32 is equal to taken as u plus a by 2 into 9. 9a by 2. Okay, got it or not? Now it is also written as 2u plus 9 into a by 2. Okay, clear or not, all the students? Now it is also written as 64 is equal to 2u plus 9a. This is the one equation. Got it or not? Next, one more equation also will get from S6 is equal to taken as 36 is equal to taken as yes u plus what is the a here a by 2 and into 2 into what we are considered here 6 minus 1. Okay, for S36 is equal to u plus a by 2 12 minus 1 for t is equal to 6 second. Okay, clear or not? Now 36 is equal to taken as u plus a by 2 into 11. Okay, clear or not? Now 36 is equal to 2u plus yes 11a by 2. It is also written as 72 is equal to 2u plus 11a. This is equation number 2. We have to solve the equation 1 and 2. You'll get and as well as the u value whatever the given here. Now there is solve equation 1 and as well as the 2. It is written as 2u plus 9 is equal to 64 and next one 2u plus 11a is equal to 72 is another. And make a minus here. Yes, it is become minus 2a. It is equal to taken as 64 minus 70. It is 12. A is equal to, yes, 6 meter per second square. Yeah, there is no answer for acceleration. It is a given for us. And now there is, you have to find out the next component. Velocity you have to find. You have to substitute the a value in this one. You get the velocity. Any one of the equation you have to substitute a value. You get the, yes, a velocity value you may get for us. Got it? Yes, I hope you got it. Yes, please note down up to here. Sorry, a is equal to 4 only. Yeah, answer is there here. A. Sixth answer is one is A, correct one only, and one more answer also may get for us. We have a place now here. Next, what we are consider, there is, you have to substitute in this particular equation any one of the equation. A is equal to 4 now. Yes, A is equal to 4 meter per second square. Substitute in equation 1. We get what we get. That is 64 is equal to 2u plus 9 into, what is the A? 4. Okay. Yes. Now 64 is equal to 2u plus 36. Okay. 2u is equal to 64 minus 36 here. Yes. And then what is the 64 minus 36 here? 28. Yeah. U is equal to taken as 28 by 2. U is equal to 14 meter per second. Yeah, the answer is C. Both answers are there, A, comma C. Yeah, I hope we complete this. Next one, there is a math. The followings are there, all the students. The math of followings are same as in our equations based. Just I want to give a hint for you how to solve it. Okay. And what they given in a seventh question, a body starts rest moves with a uniform acceleration 2 meter per second square. A is equal to what? 2 meter per second square. Where is the first one? Velocity after 2 seconds in a meter per second is. Okay, clear or not? You have to find out velocity after 2 seconds in a meter per second is a what actually we are consider. It's a start from rest, then u is equal to 0 and t is equal to taken as a what? Yeah, t is equal to taken as 2 seconds here. Okay, now u value is there, a value is there. V is equal to u plus at. Yes, from that one you get the what? The answer, seventh one answer, A answer. Okay, clear or not? You have substitute u is equal to 0, a 2, 2, that is become 4 actually. Okay, answer is become R. Yes, A is the what? R. And once take it the B, and what is that? Distance covered in the first 2 seconds in a meter. Yeah, now there is a formula you have to use. S is equal to ut plus half at square. Okay, clear or not? You have to substitute u is equal to 0 and here a and t value have to substitute here. You get it is. Okay, clear or not? What is that? 0 plus half into 2 into 2 square. The 2 cancel get each other is also 4 only. The answer is R. Okay, clear or not? Again, answer is that's why. And next one it is distance covered. That is the first 2 seconds in a meter. That is, and velocity gained after covering 4 meters in a meter per second. Okay, you have to find out the velocity after 4 meters here. Okay, now that is C purpose. You are used the what? D square minus C square is equal to 2as. They given already S value given, A value we have it, U value we have it. S is equal to 4 meter, you have to substitute. A is equal to 2, you have to substitute. U is equal to 0. Okay, then V square is equal to become what? Yes, 2as. And V is equal to under root 2as. That is get for us. Okay, the value of yes, V. Next one, the answer D purpose. Okay, you have to take this thing. Distance covered in a third second in a meter it is. That is Sn is equal to okay na u plus a into n minus otherwise a by 2 into okay, in the place of a you have to substitute here 3. Okay na here n is equal to 3 and a is equal to 2. You have to substitute. U is equal to already 0. Got it or not? By using these hints, you have to find out whatever answers are there. Already given 2, remaining 2 you have to do. And the last 8th question, integer type it is a given. What is integer type question? That is average velocity. So based on average velocity they given. Average velocity is equal to taken as a what here? Average velocity is equal to v plus u by 2. Okay, now it is a v plus u by 2. Okay, now v is a final velocity, u is a initial velocity, and as well as here average velocity is equal to v plus u by 2. Based on that one only here we consider, then answer is become n is equal to 2. Okay, got it? This is only about the concept of our first lecture. Sorry, second lecture. Now we are going with the what? Lecture number 3. Please note down these whatever the hints are there here for the math following. Yeah. Next, I'm going with the what? Next concept, that is very important. That is only graphical representation of motion. Okay, clear or not, all the students? Actually, it is in your 8th class. Already you have it here. Okay, coming to class, whatever there. Yes, earlier only are completed. There is a lesson number 12, last lesson for 8th class it is. Okay, now. Yeah, there is one check it, everything, whatever the thing it is there for a statistics based in a mathematics. Okay, otherwise, for a pictorial representation purpose, for analyzing the things, we are used the what actually graphs. Okay, our whatever the variable things in our kinematics, that will be useful for us. Okay, now yes, for analyzing purpose, for the finding purpose of the new value without usage of these all the formulas, you'll get that by the graphs. Okay, clear or not? The graphical representation, it is a very important for us. Okay, now for analyzing the one total path. Okay, now yes, whatever the motion, whatever the velocity changes, whatever the displacement changes with the time. Okay, clear or not? Yes, especially in this particular lecture number 3, we are going with the what linear motion graphical representation. Clear or not, all the students? In the lecture 3, we are going with the what linear motion of a graphical representation. Which one is the called linear motion? When one body is moving along a straight line. Okay, clear or not? When one body is moving along a straight line, it is called either linear motion or it is a rectilinear motion. Got it or not? When the body is a selected curved path, that is called what? A curvilinear motion. Okay, clear or not? These types of motions are there. You know very well. Linear motion, circular motion, oscillatory motion. These all are types of motions are there. In that one, we are now going with the what? A graphical representation of the linear motion. Okay. Now we are going with the what? Graphical representation of linear motion. Yeah. How we consider this graphical representation? Yeah, there is a different things we have taken in this one. First thing is about a displacement and time graph. Displacement and time graph, velocity and time graph, acceleration and time graph. Especially in the kinematics, we are taken these 3 types of graphs. It is also called actually ST graph or DT graph. ST graph or DT graph. Okay, suppose you take a velocity and time graph. Velocity time graph. It is called VT graph. Okay, now and when you take acceleration and as well as it is taken as AT graph. Okay, then is what is this graphs? How do we draw this graph first? Okay, yes, there is a very important simple thing. There is you have to take a time is a variable thing. Okay, now yes, with the what I have here either acceleration or velocity or displacement. Okay, clear or not? Here there is we are taken it is origin on the x-axis we are taken a time component on the y-axis we are taken either displacement or it will be taken as a what or it will be taken acceleration. Okay, like that there is we are get that graphs. Got it or not? Yes, first we are going to check about the displacement graph. Okay, clear or not? Displacement and as well as the time graph. The displacement and time graph is a given the what actually the displacement and time graph is a given about a velocity of the body. Okay, clear or not? Why? There is it here taken what? X-axis is the T, on Y-axis is the S. Okay, velocity is equal to what we have to write? Velocity is equal to S by T. Writtenable or not it is? Yes, this what you understood from this one. From this one, we'll get the what? Velocity information. The displacement and time graph is given about the finally result is velocity, and as well as there is also given the what information about the displacement variation with the time. Displacement variation with the time it will be given. Got it or not? Yes. And now then it will be check the first thing. The displacement time graph is the time axis. What it will be indicates. Okay, now suppose I am taken. There is a one line I am drawn like this. Okay, I am drawn like this. There is it is the first second. It is the second. Fourth second. It is the fifth second. Now I am taken the graph is like the card actually. Is body is the move any position here now. I am taken here. There is a one more point here. There it is a one more point here. One more point here. One more point here. Okay, what is the changes? What are not changes in this graph? According to this graph, the time is the changes. This is the first second. When you write, there is a coordinate. First, when you have to keep in your mind the three things. On which axis, which variable it is there. On x-axis, what is there. On y-axis, what is there. And what is the scale? You know very well scale. 1 centimeter is equal to, suppose I am taken here on this particular graph, 1 centimeter is equal to, one, what it is, second. Okay, on where? On x-axis. You have to write it compulsory. And as well, 1 centimeter is equal to, okay, now, yes, I am taken here, the displacement is somewhat 2 meters, 4 meters, 6 meters like that. Okay, clear or not? I am taken 1 centimeter is equal to 2 meter per second. Like that, you have to should mention the scale of that particular graph. Yes, you have to should mention there is a scale of that particular graph. Got it or not? This is only first foundation, first fundamental for the drawing the graph. When you take the any paper of the graph and after analyzing the problem, what you have to do? You have to recognize where you have to take x-axis, where you have to take y-axis. You know very well how to take x-axis, y-axis. Yes, the horizontal one you have to take as a x-axis, vertical one you have to take a y-axis. There is no problem. Whatever interchanging, it is also main not a problem. It is okay. Every time there is a vertical thing is only not called y-axis. The perpendicular with one another. Okay, should be. And on that there is according to your problem, which one is the valid, which one is the not valid. Okay, yes, for our convenience purpose, for our analyzing purpose, you have to should take. Okay, now the velocity purpose there is this. The time is only given velocity. Now that's why y-axis components by x-axis components you have to take finding the values of velocity. That is why we are taken. There is a x-axis on the yes displacement only. Got it or yeah? First you have to take like this. Now what it is indicates actually. What it is varied, time is varied here. What is the varied here? Time is varied here. There is a 1. This is the 2 seconds. This is the 3 seconds. This is the 4 seconds. This is the 5 seconds. What is not varied here? Displacement is not varied. Okay, the first second it is the 6 meters only. Second it is a 6 meters only. 7th second it is a 6 meters only. What you understood from this? There is a no change in the displacement. There is a change in a time. Okay, it is a change from 1 to 2 to 3 to 4 to 5 seconds. But there is a displacement at a 1 second. A first second it is a 6 meters only. The second also it is a 6 meters only. The third second also 6 meters only. What you get from this one? Yeah, you have to write here compulsory coordinate also. 2,6, yes, 3,6 and 4,6. Like that 5,6 and 6,6 only. Everywhere there is a what it is not changes. It's a position. The position is the same. There is a no change in a position. The body is called it is in rest. Yes, when you want to recognize one rest body, okay, at a time, okay, we have to draw which graph? This graph. Okay, now when there is a parallel line, we'll get for x-axis in ST graph. That is become what? Rest body. That is not a motive body. That is the body not a contain any momentum. Got it or not? I hope you got it. It is next. Afterwards, there is two types of motions are there. One is a uniform, another one is a non-uniform motion. Which one is called uniform motion? When one body is covered equal distances in equal time interval. Okay, that is called uniform body, uniform motion. Okay, when one body is not covered equal distances in equal time interval. Okay, clear or not? For every seconds, it is traveled or not same distances, different distances. It will be make moves. It is called what? It is called what? Non-uniform motion. Got it or not? It is called non-uniform motion. I hope you understood it is. Yes, there is a for uniform motion. How we draw the graphs? What the type of the graph make it? And a non-uniform motion, which type of the graph make it? Once you have to check it. Here there is a displacement is a given and as well as the time in a seconds also given here. Okay, clear or not? In a table they given what? Displacement is a given and as well as the time also they given. Here S is a given and this is a T is a given. Okay, clear or not all the students? There is a 0 as where at the 0th second nothing but not started here. Now first second it is moving with the what? It is moving with the 5 meters. Okay, now in a second it will be 10 May. Okay, clear or not? Then next it is a 15. Okay, now yes, third and next it is a 20 at a 4, 25 at a 5. Okay, now how it looks? It looks like a uniform motion. Correct or not? Yeah, 1 second. There is a what we are consider. Every time difference is how much? 1 second. Okay, now from year to year, how much time difference? 1 second. Year to year, 1 second. Year to year, 1 second. Year to year, 1 second. What is the difference? Is there 5 meters? 5 meters. 5 meters. Every time interval, it will be every for 1 second. The body travel 5-meter distance only. Okay, that's why this is called what? Uniform motion. Yes, how we'll get the graph for it? 1 second. I'll get the graph for it. You have to take here, then it is a type of a graph. Okay. Yes, 1 second here. Then it is on x-axis. It is on y-axis. Suppose it is a 0th. What it is a what it is origin, and here we are taken it is a what? First one, second, third second, fourth second, fifth second. Okay, got it up. Now, then it will be taken about 5 meters. Okay, clear or not? It is a 10 meters. It is about 15 meters. Okay, got it or not? Now, it is a 20 meters. It is a 25 meters. Yeah. Yes, for a 1 second, it is how much? 0 it is. Next, there is a 1, 5. The coordinate is written as 1, 5. Next to for a 2 seconds, where you have to draw point here. Okay, clear or not? For a 3 seconds, you have to draw, it is here. In a 4 seconds, you have to draw here. In a 5th second, you have to draw here. How you get here? Straight line. Okay, clear or not? What you understood from this one? It is not parallel to the any axis. Okay, clear or not? It is a straight line, increasing of the velocity, not a decreasing of velocity. Increasing of velocity may get here. Yes, not increasing, sorry. Uniform velocity is get here. Okay, got it or not? Uniform velocity may get here. Okay, no change in a velocity. Velocity is the same here. Okay, 1 second, velocity is the same or not? You have to take here as y coordinate by x coordinate. 5 by 1. It is a 5. Okay, now yes. Next, what you have to take here? 10 by 2. It is also 5. Okay, 15 by 3. It is also 5. 20 by 4. 25 by 5. Everywhere there is a 5 meters per second only. You'll get for us. Got it or not? Yeah, this is only about the what? Uniform motion. S graph where displacement and time. Yes, please note down these two.